Okay, guys, welcome back to part two of the final review guide for semester 1, 2024. We're on exponentials, chapter 3. So, exponentials come in this form. We write a times b to the x, where a is that initial value, and then the b is the factor. So that's something you want in the note card, right? So this is going to be growth. When b is greater than 1, we have growth. And then when b is less than 1 but greater than 0, we have decay. So this one over here is decay because it's less than 1, and this one is growth because it's greater than 1. Okay? So both of these would start at 2, and then this one would multiply by 3 each increase in x, and this one would divide by 3 each increase in x. So this one would look something like we start at 2, and then it would decay like this and increase like this, and this one would start at 2, and then it would increase to the right and decrease to the left. And they both have a horizontal asymptote at y equals 0. Okay? Exponential graph to equation. So when you're given a graph and you want to write the equation, you can use that same form to help you. So remember, it's y equals a times b to the x, where a is the starting position. Well, my starting position here is just 2, so y equals 2, and then it's some b to the x. Well, what I can do is, I know that 2 comma 4.5 is a point, so I can just set y to 4.5 and 2 for x, and then I can solve this. Right, so I'm going to get 2.25 equals b squared. I square root both sides, so b equals the square root of 2.25, which is 1.5. So it'd be y equals 1.5 to the x. Okay? So just remember, starting, initial value, and growth factor. Okay, evaluating logs. So without a calculator, evaluating logs, math alpha math is in the calculator, right? Math alpha math. But without a calculator, you would ask yourself, okay, 5 to what power is 625? And if I was doing this by hand and I didn't know this off the top of my head, I would say, okay, well, 5 times 5, that's 25. Times another 5, well, that's 125. And then times another 5, oh, that's 625. So the answer is 4. Okay. Ln of e to the square root of e to the third. Again, ln means log base e. So this is saying e to what power is the square root of e to the third? Well, this is the same thing, right, as ln e to the 3 halves, right, is our equivalent statement. So this is just 3 halves is the answer, because it's log base e. E to the 3 halves is e to the 3 halves. That's it. Okay. Rewriting from log to exponential. This is our base. This is the power, and this is the result. So it's 4 to the third equals 64. Exponential to log, we say log base 5 of 25 equals 2. 5 squared is 25. Okay. To expand logs, when we multiply, we can add them. So we can rewrite this as log x squared plus log y. And then we can, when we divide, we subtract. So it would be minus log root z. These powers on the outside can be moved out front, so we can have 2 log x plus log y minus 1/2 log z. Because this is really the 1/2 power. Okay. Condensing logs. We would say, well, we can move these coefficients out to the power, so we can have log 2x squared minus log 2y to the 1/3 plus log z. Okay, and so when we combine these, so we're going to use the subtraction to divide and then the plus to multiply. So we're going to have log 2x squared over y to the 1/3 plus log base 2z. And then when we multiply these two together, we'll get log 2x squared z over y to the 1/3. Okay. All right. Here's some financial stuff. So you need to know the two. This would be for the formula sheet. A of t equals principal 1 plus r over n to the nt. This is for discrete, right? So for monthly, yearly, daily, and then we have A of t equals p e to the rt, and that's just for continuous. So make sure you have those in your note card for sure. So you could be given a question with a principal and or interest rate and amount of time, and you're asked like how much money you will have at a specific time, or when will you have a certain amount of money. So we want to use this formula for A because it's a discrete period of time, and then we use this formula for B because it's continuous. So we'd have A of t, A of 20 in this case. A of 20 equals 100K, 100,000, 1 plus 0.11 over 12, because it's monthly, times 20 times 12. Yeah, on the calculator, we're going to get 100,000, 1 plus. We have $893,000. 893,501.5. Okay. If it's continuous, it would be A of 20 equals 100K e to the 0.1120. Same thing, 100 then times e to the 0.11 times 20. It's 902,501. Okay. When we have a million, assume compounded continuously. So we would say we want 1 million on the left side, and we're going to set that equal to the principal, 100, e to that rate, but the t is what we're solving for. The t is the unknown. So we divide both sides by 100K, you're going to get 10 equals e to the 0.11t. And this is when you take the log. You take the ln of both sides here. You get ln 10 to undo this e equals 0.11t. So your answer is ln 10 over 0.11 equals t. The calculator, ln 10 divided by 0.11 equals about 20.9 years. Okay. All right. Chapter 4. We've got degrees to radians. We've got some trig. So first we got degrees to radians. So to convert from degrees and radians, you multiply by pi over 180. And to go from radians to degrees, you multiply by 180 over pi. You remember this by just, okay, you want the pi's to cancel out. And also you can write on your note card. So 225 divided by 180. Math frac. So this is 5 pi over 4. And then this one, 3 times 180 over 4. This is 135 degrees. Okay? So, unit circle first quadrant. Let's go over this and make sure you understand what's going on. And then I'll kind of draw another unit circle here to the right. So you are good to use a unit circle on your test. So you can make one on your note card, but it's important to understand how to find the values and how to find different values using this note card. So we'll call this 1, 0. This is 0, 1. This is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Then we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. And we have here, these are different triangles, right? So this is at root 3 over 2, 1/2. This is root 2 over 2, root 2 over 2. And this is 1/2 root 3 over 2. And this ASTC means all are positive here, only sine is positive here, only tan is positive here, and only cosine is positive here. This is what's positive. Okay, and that's how you memorize that. Again, a note card. And so how do you find these values? Well, you can use the unit circle to find, okay, well, what is sine 135? What is cosine negative pi over 6? What is tan 7 pi over 6? So if you have a unit circle, it's really easy. If you don't have a unit circle, it's not too bad either. So where is 135? 135 is right here on the unit circle. So that is there's a root 2 over 2 value because it's a multiple of 45 degrees. So sine 135 is root 2 over 2. Cosine negative pi over 6 means to go back clockwise pi over 6. So this is equivalent to cosine 11 pi over 6. That's right here on the unit circle. And so my value there is going to be root 3 over 2. That would be my value there. Tan 7 pi over 6. So this is a little over pi. It's down here. And so it's tan. So to get your tan, you know your sine, your cosine. So right here, I'll do it below. My sine 7 pi over 6 is right here is that's going to be negative 1/2. And then my cosine 7 pi over 6 would be negative root 3 over 2. So we're going to do sine over cosine. So it's going to be negative 1/2 divided by negative root 3 over 2. That's the same as negative 1/2 times 2 over root 3. So this is negative. So this is going to be just 1 over root 3, which when we multiply by root 3 over root 3 becomes root 3 over 3. So that's tan 7 pi over 6. Okay, last page. So solving a triangle. Yeah, I mean, the idea here is just, you might be given a point. We did this in the last quiz. You're given a point, maybe it's here. You make the triangle. You're given some values, maybe like a -3 and a -1. And then you use the idea of, again, sine being up over hype to find the ratios. Okay, so, and then you have to know all of them. So let's just go over that briefly. So we have sine op over hype. We have cosine, which is adjacent over hype. We have tan, which is op over adjacent. We have cosecant, which is hype over op. We have secant, which is hype over adjacent. And then we have cotangent, which is adjacent over op. So example question, find all 6 trig functions given a point on terminal side. Point on terminal side is 2, 5. Find all 6 trig functions. So we know that there's a point here at 2, 5 right here. This is my triangle 2, 5. First thing first, we need to find the hypotenuse. We use a Pythagorean theorem. And put that on your little formula card. A squared plus b squared equals c squared. That's going to be 4 plus 25 equals c squared. That is 29 equals c squared. That is root 29 equals c. So this is a root 29 here. So now I've got that. It's pretty easy, guys. So we'd say sine theta equals op over hype. That's 5 over root 29. We got cosine theta equals 2 over root 29. And we've got tan theta equals 5 over 2. We've got and the cotangent, cosecant, and secant are just the same in reverse. So cosecant theta is root 29 over 5. Secant theta is root 29 over 2. And then cotangent theta is 2 over 5. Okay, now we got the graphing. So important to memorize or to write down the graphing notes. So where's the midline, where's the amplitude, etc. So let's do that here. So we have f of x equals a, and then your trig function, which we'll just use sine for now, sine k x plus c plus d. Okay, so a right here, this is your amplitude. The k tells you the frequency. So remember that 2 pi over k is the period. C will give you a phase shift. This is horizontal shift. And then D will give you the midline. Okay, so we're going to use that to help with these. So this first one, sine 2x minus 1, pretty straightforward. Sine normally starts at 0, but it's going to start at -1 because we got that minus 1. And the really only difference between sine 2x and sine x is that the period is now going to be pi instead of 2 pi. So it would be, my intervals would then be at pi over 4, pi over 2, and 3 pi over 4. So it's going to go up, down, down, up. And that would be it. Okay, this is -1 right here. Amplitude's still 1, okay? So go to this guy, 2 cosine x minus pi over 2. So here we got a cosine graph. Its amplitude's 2, which means I'm going to go like up to 2 and down to -2. That's important. And then it shifted pi over 2 to the right. So normally I'd start at 2 at 0, but now I'm going to start at, and I'll mark my, we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. But everything's going to be shifted 1 to the right. So instead of starting at 2 here, I'm starting at 2 here. Then it's going to come down to pi at 0, then at 3 pi over 2, it would be at -2, and then at 2 pi, it'd be back up to 0, and then over here, it would come back up to 2. Okay, so again, it's the same, it's a cosine graph, but it's just shifted 1 to the right, and its amplitude is 2. Okay, tan pi over 2x. So period for tan is normally pi. So this, you should have that down. So this is normally pi, but now the period is going to be 2 pi for this. When we're sketching tan, remember you're doing sine over cosine. So when we start at the beginning, right, your sine is 0, right? 0 over 1. And you can use your unit circle to help you with this. But you're doing 0 over 1, then you're doing 1/2 over, it's root 3 over 2, root 2 over 2 over 2 over 2, root 3 over 2 over 1/2, and then getting to 1 over 0, which is a which is a vertical asymptote, right? So I think marking the vertical asymptotes is a good place to start. We're going to have, normally we'd have a vertical asymptote at pi over 2, but it's actually going to be at pi because of the this 1/2 here. And the way we're going to look is like this, with this vertical asymptote here. And then you can imagine as we come back around here, we are going to have negative values because we're doing a positive sine divided by a negative cosine. So that's why we start here coming from below. We're going to take that 2 pi, and then we'd have another vertical asymptote over here. But that is one period. This to this is a period. Okay, secant, cosecant, cotangent. We did not do these on the quiz, but it's important to be familiar with them. Secant, cosecant. The way I would approach these is to draw cosine 2x, and then for cosecant, I would draw sine, or 2 sine x. That's really going to help you. So for secant 2x, let's just start by drawing cosine 2x. What does cosine 2x look like? Well, it's just the same as cosine, but your period is going to be pi instead of 2 pi. So it's going to start here and go down. Here, back up, and here. So remember, secant kind of mirrors this, but with vertical asymptotes. So it goes like this, and every time the cosine hits 0, you have a vertical asymptote. Get one of these, and then one of these. Not too bad, right? Same thing for 2 sine x. Draw 2 sine x, and then sketch. So 2 sine x, we're just going to start at 0. It's going to be regular 2 pi, 3 pi over 2, pi over 2. So it's going to go up, back to 0, down to 1, back here. But it's going up to 2. So this is 2 and negative 2, but it's the same idea. It's going to look like this. Vertical asymptote at 0. Vertical asymptote here at 0. Okay? And these would be touching here. Okay? And then cotangent x minus 1. So cotangent x looks very, very similar to tan x, except our vertical asymptotes happen at different spots because cotangent is cosine over sine. So you're asking, okay, where's cosine 0? Well, cosine 0 here and here. Cosine 0 here and here. So these are where my values are 0. Where sine is 0, you have vertical asymptotes. So we can go ahead and just sketch at 0 and at pi, and at 2 pi, we're going to have these vertical asymptotes. Okay. And then we're shifting down by minus 1. In the midpoint here, so at pi over 2, that's where my cosine is 0. I'm going to be down here at negative 1. And at 3 pi over 2, I'm going to be down here at negative 1. And then rather than it going up from the left, cotangent decreases, so it comes down like this. Okay, that is it. That is part 2 of the final review.